Let's suppose if we consider the concept of work power energy. So basically, we have to start a new chapter, that is work power and energy. And if we talk about the first concept that is related to the energy, because we know about the energy concept. Walaikum Assalam. Because we start with the energy, we all know about the law of conservation of energy, that energy can neither be created nor it can be destroyed, but can be transformed from one form to another form. So that is the law of conservation of energy. So that's why we know that energy remains. Uh, we are not able to create or destroy the energy, right? So basically, if we want to write the energy, we can say that it is a property that must be transferred, that must be transferred to an object to perform work or heat up that object. So basically, in this chapter, we have to discuss the concept like this. We need to combine work, power, and energy concept. And if you want to write another definition, so another definition will be like this: a very straightforward statement. Ability to do work is known as energy, right? So basically, both are the right statements for the energy depending upon the situation, because most of the time they never ask about the definition. But sometimes if they ask for 1 mark, so both definition will work for you. And for the SI unit, most of you, I hope you know about the SI unit of energy. So the SI unit of energy is joules, that is capital J, right? So this is the SI unit and this is the concept of energy. And basically, we have to categorize all different types of energy into two categories, right? We have two categories of energy. The first one is kinetic energy, and the second one is potential energy. So basically, these are two categories for energy. These are the journal categories. And further, if we talk about the individual type of energy like mechanical energy, heat energy,
So I had a
thermal
question.
energy, yes.
In the exam, if it asks us for like the definition of energy,
Hmm.
which definition do I give?
Basically, they mostly ask for 1 mark only, right? So both definition will work for you, right? They both, in
All
both
right.
concept, you will get 1 mark, right? Because in the first definition, we are just like explaining the thing, right? We just
Yeah.
explain simple words to an object to perform work done, or we know that when we try to work done, so heat will also produce, right? Because nothing is 100% efficient. No machine, nothing in the world is 100% efficient. So it means that some part of energy is converted into the thermal energy, right, or in the heat energy. Okay, so that's why there is
Okay.
always a concept of heat in the concept of energy. So basically, there are two categories of energy only. But in general, if we are talking about like daily life example, like solar energy, wind energy, or tidal energy, or these are the different types of energy. But if we want to categorize them, so either we need to categorize them into kinetic or either into potential, right? So first of all, if we talk about the kinetic energy, so basically, the kinetic energy is, so we can simply define the kinetic energy as energy due to a motion, right? So let's suppose if car is moving from one point to another, right? So we can say that the energy at that time of the car is kinetic energy, right? Because we can easily identify the energy because we know that if car is moving, right? So definitely there will be a fuel in the car that helps the car to move from one point to another, right? So basically fuel is a like type of chemical energy, right? So that chemical energy help the car to move or to convert that form of energy into the mechanical form of energy, that is kinetic in simple, right? So all
Yeah.
moving objects gives you the concept of kinetic energy because it is related to the motion. We know that if we consider them in the if we are going to drive all the thing to the basics, so we get different type of energy, right? Just like we talk the example, take the example of the car. So in car, what we need to do, we need to discuss like that. If we take the example of a car, so in example of a car, we can say that there is a chemical energy, right? Chemical energy in the form of fuel, right? So fuel gives you the chemical energy, and that chemical energy, because we know that when fuel burns, so it will help the car to accelerate or to start to move from point. So this chemical energy converts into mechanical energy, right? Mechanical means when you are doing work, like when we are walking, so that is also known as mechanical energy, the energy due to the motion. So that is known as mechanical energy. So the motion of the car shows you the concept of mechanical energy, right? So this is the concept of kinetic energy. And the formula for the kinetic energy is half mv square, right?
Uh,
And the quantities given in the formula is, this is the mass of a body and this is velocity, right? So this is the formula for kinetic energy. And if we consider the second type of energy, second category, so that is known as the potential energy. Okay. So the next one is the potential energy. So for the potential energy, we can say that the energy due to a position of a body is known as potential energy, right? Just like we discussed the chapter of elastic deformation, right? We discussed the concept of gravity, elastic potential energy over there, because when we try to stretch the rubber band, so there is also a restoring force. There is a concept of restoring force, or we can say that the potential energy or elastic potential energy is stored in the rubber band, right? Or let's suppose if we consider another example, the other another example is if we place a ball or any object on stairs, right? So if we place object at two different distances, so let's suppose if we take two different heights and we place object on it, so you know that when we drop all these objects or these balls from the height, let's suppose this is one, this is two. So when we drop or we just slide these ball on the horizontal surface, so after reaching the corner point, they will definitely fall freely under the influence of gravity towards the ground. So which ball will bounce back with greater amplitude or with greater distance? So which ball will bounce back with greater distance? The first one or the second when they strikes the ground? Ball one will bounce back with greater height, or ball two will bounce back with the greater height? So basically we know that if we talk about ball number two, will bounce back with high amplitude, because we know that the height at which the ball is placed, so it will gain more potential energy due to the gravity, right? So because as far as you move away from the earth and then you start to fall freely, so you will get more potential energy as far you are moving away from the earth surface, because we know that we are moving in the opposite direction, so we are getting potential energy. Just like the rubber band, if we stretch the rubber band, right? So the energy stored in the rubber band is known as elastic potential energy. And when we release the rubber band after stretching them to the greatest height, so you will get more force by the rubber band on the body, right? And if we talk about the formula, so formula will be potential energy is equals to mgh. And from formula, you can easily identify that it is more likely to be the same as the pressure in liquid.
Wait, isn't liquid rho GH?
Yes. So mostly it this formula is more likely to be the pressure in liquid, only there is a difference of density and mass, right? Otherwise, we are having a same thing, because in that we are also calculating with the depth, and in the potential energy we are also working with the height. Okay. But only there is a difference of density and mass. Otherwise, the formula is same, because that is for liquid and this is for solid.
Density is mass over volume, right?
Yes.
So this is just density times volume.
Yes.
Okay.
Because we know that in liquid we need to have volume, right? but in solid we can only work with the mass because solids have definite shape and definite volume. So that's why we don't need to consider volume every time in solid. We can just compare them with the mass. And from the formula you can easily identify the more you are away from the earth surface, or when you are at the most highest point from the earth surface, so more you are getting the potential energy, right, or the gravitational potential energy.
All right.
And we also know that the SI unit for potential energy and kinetic energy remains same because these are type of energy. So SI unit will also remains the same, right? And there
Yeah.
are multiple.
So I had one more question.
Hmm.
And after I saw G, I got the question. So, gravitational acceleration rate, I don't remember the exact term. I
Hmm.
thought it was 10 meter per second squared. Is
Yes.
it 10 or 9.8?
Basic
9.81.
now in new exam specification from May June 23, they used to give you the value 9.81. Before that, we are using round figure 10, because actually the reason is that when we are going to round off the value, right, so in A levels it is compulsory to round off the value to two significant figures minimum. So they use the value 9.81 in IGCSE this time because students try to practice to round off the values from their IGCSE level, right? So it will be more easy in their A levels, right? So that's why this time we are using 9.81. That will be mentioned on the top of the paper, just like when we are solving the past paper. So value is given on the paper, right? So just for the reference, they mention in the syllabus changes that from May June 23 till 25, we are going to use the value 9.81 meter per second square. Okay.
All
So
right.
that value is given on your paper, no issue, right? But for from now we are having 9.81. And there are different form of energy that we are going to discuss in this chapter. Like some of them we already discussed: the kinetic, the mechanical, the potential, the chemical, the elastic. So there are different form of energy, right? We are not going to discuss them one by one, because during the different concepts we are getting all the things in this chapter. So we don't need to write them individual and to discuss individually them. uh, Next thing is, we got the concept of kinetic
But
energy.
sir, what is like, I have a question.
Hmm.
So if both of these balls were stationary,
Hmm.
does ball number two still have more
Yes,
this
potential
this
energy.
does ball number two still have more energy like inside of
Yes.
it compared
Yes.
to ball number one?
Yes, because you know that if you are carrying your bag and right, and you are walking on the stairs, so after just covering some distance on the stair, you feel very tired, or like you have to apply more force because you are taking an object away from the earth surface, so the energy is going to be stored in the bag, and
Oh, okay.
you
So
need
that's why it's
to.
easier to go down a hill
Yes.
than up a hill.
Yes. Yes. So that is the
Okay,
concept.
okay.
So you need to do more work over there, right? Because we know that
Yeah.
concept of energy in simple word is ability to do work, right? So basically,
Okay.
when you are taking object against the gravity, so basically you are doing work. Okay.
All right.
That is the concept of uh, the potential energy, because the next thing is related to the work done. And the formula and the concept of is work done is more likely to be equal to the moments, because in moments we discussed that force into momentum is uh, equals
Force
to
into
the
D.
moment. Yes, F into D. So same thing we are going to use in work done. That's why we use the concept of momentum over there. Otherwise, both formula, both concept will be same. So basically, work done is the product of force and displacement is known as the work done. Or in detail, you can write this definition as when we apply a force on an object, so body will displace in the direction of force, right? So you can also write the concept like this. Otherwise, I just mentioned that point over here. Body will displace direction of force. And now you can see that formula will be same. W equals to into D, right? But only the difference is we studied the concept of
This is
motion in
displacement.
the, this time we are having displacement. So that is the difference. That's why we use a different concept over there. Otherwise, both concept will be same. Now you got the concept that when you are taking your bag with you along the stairs, so when you are moving against the gravity in upward direction, so basically you are doing work because you are applying force. You are actually just covering a distance or displacement from one point to another. So basically you are doing work against the gravity, right? Just like if you just like the example of the angry bird game, when we try to just stretch that rubber band, right? So the more you stretch that rubber band, so the more that bird got angry or got more energy, and that will cover more distance, right? So simply that is the concept of distance. Because when we stretch the rubber band, so we are not able to see the energy by our normal eye, right? But when we just observe the effect of that rubber band, so then we are able to understand that yes, this type or this much energy is stored in that rubber band, right? Because it is due to the position of a body, so it depends upon the position. So the more we stretch the rubber band, so normally we observe a thing. It is natural concept that we got the idea that yes, we got a long distance or a long range after just releasing from that point. But in kinetic energy, kinetic is due to the motion, so that is very simple, we can easily identify with the help of the movement of the body, right? Any confusion?
Yeah. No.
Okay. So formula is also very simple. And if we talk about the SI unit, so SI unit is also joules. Basically, 1 joule is equals to 1 Newton into meter, right? Because we know that the SI unit of force is Newton, and for distance we are having meter. So that's why energy transferred is also equals to the work done, because in both we are having same SI units, right? So basically, we discussed the concept of displacement with the force. Let's suppose if you are applying a force on the box, and box is going to displace in the forward direction in the direction of force. So we observe that we are having a same direction of force and displacement, right? So in that concept, the object will gain energy, right? Like the kinetic energy. Okay. And let's suppose if we apply force but in opposite direction, so then we lose our energy, or we can say that we are getting potential energy, or just we are losing energy in form of thermal energy, or we are just losing our energy to our surroundings. Let's suppose if we consider two directions, if we consider an object, and if we apply force on it, and displacement will be in the same direction. So in this condition, we can say that the direction force and displacement is same. So we can say that body or object,
Will move.
yes, it will move plus it will gain, because we are talking now with the reference of energy and work.
Kinetic energy.
Yes,
Oh
so
yeah, kinetic energy.
to write generally, so we can say that energy, but if we want to write specifically, so we can say that
Kinetic.
kinetic energy, right? And let's suppose if we are moving against the gravity, or we can say that uh, the force act in the opposite direction to the movement, like let's suppose if we just lift any object, right? So when we are lifting the object, so what actually happens over there, that the weight of the box is in downward direction, right? And the displacement will be in upward direction. Basically, there is a very detailed concept of we can say that the work done, but that is not included in our syllabus, because when we apply force in the direction of displacement, so your angle will be zero. So basically, in the first diagram, we can say that your angle between force and displacement is equals to zero, right? So when your angle is zero between force and displacement, so you are getting maximum work done, right? But let's suppose if you are having a perpendicular concept between displacement and force, how that was possible, I will show you that also. So let's suppose if you consider another example, and in another example, let's suppose we consider 90-degree angle between force and displacement, right? So how that was possible, let's suppose uh, if we take the example of let's suppose if we take an example of a mini crane, like just we use in the supermarkets or in the superstores to lift the cartons or to lift the different heavy objects from one point to another, right? So if we consider the example of that mini crane, so let's suppose if crane is lifting some object over there, this is our type of crane we are using, okay? So basically, when we try to lift that object, so basically the main purpose of the crane is, the first main purpose of the crane is to lift that object, right? So basically the weight of the object is acting in downward direction, and normal reaction will be opposite. So basically the force is acting opposite to the weight. So the main purpose of the crane over here is first to balance the force of the weight. So both are in opposite direction. And the second thing is that crane is moving in forward direction, right? So this is the direction of displacement, but the force applied by the crane is in upward direction, right? Because you can see that there is no force acting on the block in forward direction, right? Because there is nothing that pushes that block from left to right. Clear?
Yeah.
So you can see this is the direction of force, and it is completely perpendicular to the direction of displacement. So basically, in that case, you are doing zero work done, right? Because both are perpendicular. Because force is in different direction, displacement is in different direction. So basically, these are some categories of work done. So we will get a maximum work done over here because both are in same direction, and we are having zero or minimum work done over here when both things are perpendicular to each other. And the final thing is, let's suppose if both are in opposite direction, like 180 degree. Okay, 180 degree means, let's suppose if we consider any bird, or we let's suppose if we consider eagle is flying in the air. So if we consider the example of an eagle in the air, so again the same concept is, the main purpose of the eagle is to fly in forward direction, but again there will be a force of air resistance in backward direction, right? Okay, so we apply a force.
Streamline shape.
Yes, we apply force to overcome this air resistance, right? So basically, the force applying on the eagle is in backward direction, right? So that is the direction of the force, and the main purpose of the eagle is to move in the forward direction. So basically, when we apply force, so our force actually try to overcome the air resistance, but we know that in this condition we are having different direction. We are not just working in the same direction, just like the first object, right? So normally we overcome the force, right? We overcome the air resistance, but actually what happens? Some of our energy converts into the thermal energy, right? So we can say that some part of energy converts into the thermal energy. So basically, these are some different types of example. The main purpose or the main concept of talking about all these examples, because when they ask about the theoretical concept, so we have one concept that if there is some opposite force acting on the body, so we have to write the concept of thermal energy or the concept of resistive force over there, right? So that is the main theme of the topic that we need to discuss. Because we know about the power, we will further discuss about different types of power and different concepts. So that is the concept uh, in the chapter of work energy power, because we discuss about energy, and further with the time being we will also discuss about different types of energy conversion, like how the windmill works, how we can generate electricity from water, how to generate electricity from fossil fuels. So all these
Oh
examples.
yeah.
Yes. So all these things are very much important in this chapter. You find many questions related to these things in your past paper. And one more important concept is that how we use dams or how we use turbines to generate electricity. There is a complete proper procedure, because in your exam they just give you the same diagram with missing components in the diagram. So that is very much important. So in next class we will start with that energy transfer process, that how electricity is generated from the turbine. We need to know about all the name of the components, and then we will discuss about different forms of energy, right?
All right, sir.
Okay,